Hey guys, what we're going to look into today is number patterns. Okay, but specifically, we want to look into how to create an equation using or trying to figure out an equation to explain number patterns. Number patterns are often feared by some students, and well, because quite often we fear what we don't understand. So sometimes students just don't understand number patterns. It's not hard to figure out what's happening in a number pattern, but to explain it using an equation is difficult because there's a few steps to understand, and quite often we don't know, or students don't know, what exactly we're talking about when we're creating that equation. So I've listed some steps here that will hopefully help. So the first thing that we do when we look at a number pattern is we try and figure out what exactly is going on in it. So quite often you'll be directed to figure out, okay, well, what's happening? How is the number changing as it moves from one step to the next? So we'll look at the first one here. It's clear that it seems to be going up by 2 each time. Okay, so that discovery allows us to explain the pattern. I mean, it starts with 3 and it goes up by 2. But if you were asked, okay, well, what happens when we do this pattern 500 times? What will be the answer in step 500? What will be the answer in step 2000? Okay, so when that kind of stuff happens, well, when we're asked to do those, we're going to have to come up with a better way of figuring that step out without actually, I'll just take this off, without actually doing the number pattern 500 times. That would not be very enjoyable. So what we've done here is we want to think about the pattern. Okay, we realize it goes up by 2 each time. Now we want to do something called to create an input-output chart. It's not, the input actually doesn't change. It's actually a term number. So basically the input in our number patterns, and this is what causes confusion, but the input is actually just the stage of the pattern. So the first stage, second stage, third stage, etc. We call that the term number, and we're going to actually represent it with an algebraic variable, which we're just going to say that is n. Okay, a variable changes. It's just a letter that represents maybe whatever step of the pattern it is. So maybe n will be the step number 500 or 1,000 or 2,000 or 1,000,000. It's the same as putting a blank there. We're just actually representing it with a letter. Okay, so whatever that step is, that's the term number, and we represent it with n. The other part of the chart is our output. So our output is going to be whatever the answer is at that stage of the number pattern. So we have the term number, which is stage 1, 2, 3, 4, and 5 is as far as our pattern goes. Our output with the first pattern is 3, 5, 7, 9, and 11. Okay, so we're organizing our pattern in terms of its stage. Stage 1, it's 3. Stage 4, it's 9. Stage 5, etc. We want to figure out which stage 500 is. So we're going to have to come up with an equation. So what are we doing to our n in order to create this output? And whatever equation we create, whenever I put any of these numbers in, it should create our answer. So our pattern goes up by 2 each time. What that tells me, and this is when you start getting used to patterns, is if it goes up by a certain number each time, it's quite often the case that you are multiplying the term number by 2. Okay, so this is how that equation would look. It would be 2 times n. Okay, I don't know if you remember, but when we put a number beside a variable, it means that they're multiplied together. Okay, so if I was to plug in 1 into as n, it would be 2 times 1, which would be 2, okay? Well, that doesn't give me the answer of 3, so why don't, but I know it does, I can add 1. So 2 times whatever the term number is, plus 1. Well, that gives me in the first stage an answer. Well, here, we'll plug it in. So if I go 2 times the first stage plus 1, that's 2 times 1 is 2, plus 1 is 3. So that gives me the first one. So now the next part. So we created an equation, used our understanding of the patterns, and we now have has figured out, okay, I have one equation that works for the first step of the pattern. 2 times the first step plus 1 is 3. So let's try the second step. So now I go 2, I plug in the variable, well, I plug in 2 now for the variable, because it's the second stage we're looking into. And I add 1, well, that equals 5. Okay, so good news, 2 of the steps we've actually got it. So let's move down and let's actually plug in 5. So let's plug in the fifth step of the pattern. And let's see if this equals, so it's 2 times 5, which is 10, plus 1 is 11. Okay, so we've done it 3 times, and it looks like no matter the first 2 steps and even the fifth step of the pattern, this equation works. Okay, so we've actually successfully created an equation for this pattern. So now I can use this equation for any step of the pattern. So if I want to find step 500, I would go 2 times 500 plus 1, and that would equal 2 times 500 is 1,000. So this one would be 1,001. Okay, so that's how we create an equation. You just need to understand that you're creating an equation for when I plug in the step of the pattern or the term number, that the equation produces the output every time in the pattern. Okay, and so we can use this equation to figure out any step. For the next one, we have, I'm going to use the same chart, but I guess I'll use this and this marker instead. So now the output is 2, 5, 8, 11, and 14. Okay. So I use my experience with number patterns, and so the first thing is I'm looking, okay, what's changing in this pattern each time? Well, actually, in this case, it's going up by 3. Okay. So we know that when it's going up by 3 each time, it's most likely an equation that deals with multiplying by 3. So we'll try the first step, and so we'll create so we'll go 3 in this time. So I'm multiplying 3 by the term number. And so if I look at the first step, if I plug in 1 here, it would be 3 times 1, which is 3. Okay, but I have to get to 2. So, well, one way of doing that is we can actually subtract 1. So now let's experiment with this and see if that works. So it would be 3 times 1, subtract 1, that produces the output of 2. Okay, let's try the third step in the pattern. I'm going to plug in 3 in my equation, see if it works. Okay, 3 times 3 is 9, minus 1 is 8. So that works. Remember, it's the brown here that we're dealing with. And then we'll go 3 times 5. Okay, that is minus 1 equals, that's 3 times 5 is 15, minus 1 is 14. So now we can see that we tried it 3 times, we have a pattern that works. I do suggest that you try it 3 times, it becomes especially, and you know what, go to the third step, the fifth step, because what happens is some funky patterns actually you'll have the wrong equation, and it will give you the right answer for the first 2 steps, but then things go wonky, and so you want to experiment with a few other steps. So if this is our equation, then if we want to figure out the 500 step of this, it would be 300 times 500, or sorry, 3 times 500 minus 1. Okay, so that's 1500 minus 1 is 1499. Or 1,499. Okay, so that's how the equation works, or that's how you create an equation out of a number pattern. Okay, so hopefully you understand that when we're creating an equation, we're using the term number as our input. Okay, our output is whatever the answer is when we input that term number. So when we're creating equations, we're using the term number as our variable. So hopefully that helps you out. Let's see if you can create your own equations for number patterns.